subject that we're going to talk about today, and that's going to occupy our time, is communicating water science creatively. We call it From the Lab to Classrooms and Communities. And I want to talk about a little bit why that's an urgent problem. And then I also want to say a little bit about what Water UCI, the center that we work in at UCI, is trying to do in modest ways to try to help this effort in science communication. So I'll start by reminding us of some recent events in California. A quick quiz. Where is this? Anybody? This is Lake Oroville, one of the northernmost features of the State Water Project that provides water for all of us here in Southern California, as well as in the Central Valley and also parts of Los Angeles. In May of 2015, I had the privilege of attending a group that was sponsored by the Metropolitan Water District to visit Oroville, when, as you can see through this great mud flat, the reservoir was about 40% of capacity. Less than 2 years later, we had, of course, that notorious flooding event in Northern California, which, as you can see from this picture, actually breached the dam and breached one of the spillways and caused damage, which is still being repaired today. Estimated cost somewhere in the order of $100 million to repair. Is this the new normal? This vacillation between drought and flooding? Or is it abnormal? These are pictures taken a little over 3 years apart. This, of course, is Hoover Dam and Lake Mead. And again, you can see this large bathtub ring around the reservoir. Lake Mead is also down to about 40% of capacity. And if it continues, and in this case, this appears to be a new normal, there's not going to be this variation in the Colorado River between drought and flooding, but just really chronic water shortages. And we'll talk about a reason why that's so just momentarily. But basically, this second picture is, I think, very instructive because these towers are what are called intake structures. They take water from Lake Mead and they run it through a power plant. And some of that power provides electricity for us right here in Orange County. If this reservoir continues to drop about another 20 feet, there will not be sufficient water to be able to go into these intake structures and generate electricity. So the connection between water and energy is a profound one, as all of us know in this room. And if this is the new normal, we really have to be concerned about this. So, climate change, many of us believe, is strongly implicated in this situation. And it affects water, and it affects future, and it is a science and a policy challenge. Quickly, I want to just note a couple of things on these two figures. The one on the bottom left was provided by the Public Policy Institute of California. They've been doing a lot of work looking at the way in which we use, or as it may be, overuse water here in California and throughout the Southwest. This figure on the bottom left is only for the Colorado River, which is a major source of water supply for our region. It really is the major source of water supply for 7 states in the southwestern United States. And as you can see over time, really, even after Hoover Dam was completed, which would have been in the 1930s, right about here, while the reservoir level stabilized and actually went up in the 80s, it's been on a steady decline. Yet, water use, indicated by this mustard line, is increasing to the point where we're using more water from the Colorado River than is actually available. You might want to ask yourself, how is it possible to use more than is actually there? And the short answer is because some of it is banked and stored in reservoirs. But nevertheless, this trajectory cannot continue without dire consequences for our entire region. And why is the water use going up? Because there's more of us making more demands on water supply for agriculture, for our cities, for electrical power, for just about everything that we do in our daily lives. And the water supply is diminishing in part because of diminishing snowpack. We had a very small role in this global change research program study that was produced just last year. Basically, what we did is we looked at the demand side of this problem, but basically this tracks the supply side. Snowpack is the fundamental source of water for the Colorado Basin. And what is predicted over time, as you can see, is that in virtually every one of the states that feeds the Colorado River over the next century, really by the end of this century, snowpack will diminish. And this is a very, very alarming trend. So we've got to somehow figure out a way to get the water that we don't have. So this is a science challenge. It's a science communication challenge. As many of us know, it's also a policy challenge because we have to somehow figure out a way to change the way we manage and use or overuse water. Which brings me to this somewhat rhetorical question: is it also an education challenge? This is a recent study, a series of polls I want to talk just briefly about. These were done this past January by the Energy Policy Institute at the University of Chicago, working together with something called the National Opinion Research Center. And you can read these bar graphs yourself, but there's a couple of really striking issues that I think all of us probably are not very surprised about, given the state of our society today politically and how polarized we are, but it's really quite alarming in terms of science communication. It turns out that there's a considerable difference between those who consider climate change to be caused entirely or mostly by human activities by partisan affiliation, or I suppose to translate that into plain English, by one's political philosophy. Over twice as many people who identify themselves as Democrats believe that climate change is caused mostly or entirely by human activities. A little over 30% of Republicans feel that way. And independents, not surprisingly, somewhat in the middle. When you look at the causes equally by human activities and natural changes in the environment, again, a difference of opinion depending on public opinion and political philosophy, and then that it would be caused mostly or entirely by natural changes in the environment. Again, very sharp differentials. So this isn't just a question of do you believe in climate change, but if you believe in it, what causes it? Is it just a natural thing or is it caused by us? And the partisan differences here, really striking, which suggests that there's some real challenges in communicating science across political philosophies, and a huge challenge from the standpoint of education. Thought you might appreciate this cartoon, which I downloaded from the internet. Actually, when I first read this, I thought this is so funny, it couldn't possibly be true. But of course, as recent events suggest in our society, this notion that a storm will either bring devastating flooding to coastal areas or doesn't exist, depending on one's political philosophy, may be more true than we would like to believe. So what can be done? And several answers to that, but quickly I want to race through some things that are going on in our society and that we in Water UCI, in bringing together thought leaders from industry, from the scientific community, from universities, are trying to do to address this. Let's start with the premise that what we want is resilience. Droughts are natural. Climate change appears to make them more frequent and more intense. And our behavior, our demands for water, worsen them. Resilience, we think, is a transition to renewable, low-energy water sources and the use of integrated management and conservation. How do we do this? Well, to reduce demand, to conserve, in other words, to avoid wasteful uses, which sounds a little redundant, but basically it goes beyond conservation by asking, are there things that we use water for that maybe we don't need to use water for? Do we have to irrigate our lawns? Do we have to have lawns? It would be another way, perhaps, of phrasing that. Becoming more efficient. Reusing every drop. The recycling of wastewater is an important issue in the Southwest and becoming important throughout the world. And harvesting new sources of water. Perhaps when it does rain in Southern California, while infrequent, if we could somehow capture that, harvest it, and reuse it, we might be able to get a little bit ahead of the problem. Education is needed, research is needed, and public outreach are needed. These two pictures on the right are products of some Water UCI sponsored events. The first took place in 2015 in cooperation with the American Geophysical Union. We had a conference involving researchers from virtually every research university in California, from throughout state agencies, and a number of students were in attendance, looking at the causes, impacts, and policy implications of California's drought, which was really just underway at this time. We also produced an article in Nature talking about the problem of what we call anthropogenic drought, which is to say droughts come, droughts go, but what really makes them bad in our current era is not the coming and going of the drought, but how we manage water during the drought and whether or not we're doing enough. So how do we achieve resilience? And here's an example. Some of you are familiar with the actor Wilford Brimley, and kind of a parody on the notion of recycling water and making it attractive. Flushing after filling each bottle. The product Porcelain Springs. I don't know if this really exists, but it's an interesting problem nonetheless. Resilient options for managing future water needs have to meet a number of criteria, we believe, and our colleagues believe, and the people with whom we've worked at Water UCI believe. Obviously, an option has to be technically feasible. The science and engineering have to support the option. Can we recycle wastewater? Can we distill seawater and produce fresh water? Yeah, we can do that. So the technical feasibility part, that's fairly straightforward and can be done by engineers. But we also have to entertain the possibility that an option may not be as economical and fair as society would want it to be. So if we're talking about resilience, we can't just focus on the science and engineering, we have to focus on affordability and equity. And the only way we really know that is to compare options against one another. And this is something that we've been involved in some efforts, and you'll learn a little bit about that in just a moment. Also, environmental impacts and risks. How many of you know that every option to manage water has some environmental impacts and risks? Does desalination have risks? Does the recycling of wastewater have risks? Does conservation have risks? Could affect, for instance, the revenue stream of water agencies. It could affect certainly the built environment, how we manage it. So everything can produce adverse impacts, but the key question is, can they be mitigated in a way that's societally acceptable? Which brings me to the last of these criteria that we think are important for resilience, and that is public acceptability. This is a keystone that is too rarely discussed in water conversations about conservation and other things, but needs to be embraced. The public has to trust various options, they have to have confidence in them, and they have to have a voice in how they're implemented. This is something that Los Angeles is now learning in terms of the option of recycling wastewater, something that we have, I think, learned fairly well in terms of Orange County and embracing the public, but it's something that needs to be done throughout the world in terms of achieving water resilience. So what about us? Well, this is a picture that was taken just outside here in the Beckman Center some time ago, accompanying one of our Water UCI events. Our goal as a center, when we were formed 5 years ago, was to foster a conversation around water among faculty and students here at UCI, but then to reach out that conversation to industry and to the global community. And that means all of you in the audience today. Our foci are threefold. We have a big education component, as you'll see. We have an outreach component going out to various publics and actually helping to try to educate and inform people about these issues, and to undertake what we call engaged research, not sitting in our offices and thinking great thoughts, but bringing people together in meetings like this, engaging you, distilling and synthesizing your ideas, and then coming up with research ideas and projects. In education, we have a summer field studies program, which has been going on for a few years, mostly for graduate students, though we have had some undergraduates involved in this. We take them out to sites all over the region and basically expose them to the various disciplines associated with water and the various problems. And the neat thing about our region, as all of us know, is that within a 100-mile radius, and yes, that does include the ocean, you can find just about every global water problem in a 100-mile radius of Irvine. So that's a real fun thing. We have fellows that we award small grants to do research, and we call it the Water UCI Fellows Program, and they give research presentations. One summer, we had a group of students that went out and spent part of the summer in Borrego Springs in the Anza Borrego Desert, and they produced a poster presentation for members of the community on ways of conserving water. And the interesting thing is this was a group of interdisciplinary graduate students from throughout UCI, and to come up with a title for what they wanted to do, the best they could come up with is wildflowers, citrus, and swimming pools, kind of encompassing everything about water that we know in the California desert. What's there naturally, how we exploit water, and how we sometimes use it for our own comfort. Picture at the bottom are some of our students that have been involved in these summer programs. We also have, very proud to say, a program that extends to middle schools here in Orange County. Basically, this is to educate middle school students on water conservation. Students from UCI work with middle school teachers throughout the area and their students to actually come up with projects that will demonstrate innovative means of water conservation. It's definitely education, but we like to think of it as going even a step beyond education. These young women and men are extremely curious about the world, and they are going to be tomorrow's water leaders. Whether they work in water agencies or government, or simply whatever they do, they're going to be leading innovations in thinking about water. So we're very proud of this effort. Recently, we have partnered with the Bolton-DeGale Water District, one of our local water agencies that we've worked with on a number of things, and they want to promote and help us bolster this effort and take it throughout the county, and so we're very excited about this opportunity to do so. And as you can see, the students are very, very proud of their achievements. We give them these certificates of achievement, and they also get to do their presentations annually here at UCI. Stay tuned. You'll get a chance to see this current crop this coming May. Public outreach. You know, when we talk about water and we talk about science and we talk about communication, we also often think about water as a very technical enterprise. But what about the arts and the humanities? A couple of years back, we had a plastic ocean art exhibit, which featured a very well-known artist from the University of North Carolina, Wilmington, who basically collected plastic trash from a portion of the Atlantic, and there's so much out there that you could spend, unfortunately, several lifetimes just collecting the trash, and turned it into various works of art, as you can see displayed here. The idea here was to show not only the gravity of the problem facing the world's oceans, but to create and entertain an interdisciplinary conversation between artists like Bonnie Monteleone, Francois Promot, and Simon Penny, two scholars here at UCI, one in the School of the Arts, one in the School of Physical Sciences, to actually have a dialogue about this problem of the plastic oceans and how plastic congregates in certain areas. Very educational effort, very informative, and a good example of the kind of public outreach that makes people more aware of water. We also partnered with UCI Libraries some time ago to do a series of talks and exhibits and other activities, as you'll hear in just a moment, on water in California. Part of it involved an exhibit on the history of how we manage water. Part of it involved, and this was really a splendid experience, the School of the Arts, the dance company actually prepared a dance devoted to water and performed for people in the science library. It was an astonishing experience. And the idea is really to convey to people that the arts, the humanities, the performing arts, all can be brought into the conversation about getting people to be more aware of water. And being good academics, we collaborated with some people in the European Union to produce a paper indicating how, in fact, others can be brought into the conversation to unite scientists, politicians, artists, and citizens around water issues. This is something that in Europe has been going on for a bit longer than it has been in the United States, but it's something that we feel ought to be really readily adopted here in California. We also engage with the community very briefly. We do a lot of colloquia. Many of you in this room have attended these colloquia. We deal with any topic, any and every topic of relevance to understanding the management of water, from international water conflicts to transitioning to a renewable water economy, to water policy and planning in a changing climate, to just the future of water in Southern California. And these are interactive conversations. These people who are experts speak on these issues. They interact with our students, with our faculty, with members of the community, and this really signifies this idea of a conversation around water. Engaged research. I mentioned the fact that the kind of research we do is not just sitting in our offices and thinking, conjuring up great thoughts, but engaging thought leaders. We have done some work on the Water Energy Nexus. One was a conference that was held here in the Beckman Center by the United States Department of Energy, and we produced a report for the Department of Energy and some papers that were published in more or less popular industry or trade journals to get the conversation out in the larger community, to identify solutions that would ensure reliable access to energy and water. Remember our picture of Hoover Dam? The link between energy and water is critical. To address climate adaptation and aging infrastructure. How many of you know that both our water and our electrical infrastructure has some problems here in California? Yeah, that's definitely been in the news. And to pursue innovations that acknowledge how water and energy systems are connected. I mentioned rainwater. We were involved in a study that was supported by the State Water Resources Control Board about a year and a half ago, and other partners here in Southern California and Northern California, looking at how we can optimize the management of stormwater. This picture on the bottom left is a schematic that was provided by the Los Angeles Department of Water and Power. And basically, they already have plans in line to try to increase the amount of stormwater that's already captured in the city and that runs off the mountains and the foothills, and to spread it within the groundwater basin, and also to capture it in streams, creeks, and rivulets, and somehow reuse it. Right now, 27,000 acre feet, that's about enough water to support some 200,000 people, if it could all be reused as potable water. And Los Angeles would like to double or triple that by in the next 15 years. There was a ballot measure called Measure W last year, which was actually approved by the voters in Los Angeles County and will permit the city to put a small parcel tax on real property to basically create ways of harvesting and storing and creatively using stormwater. We did a study that looked at approaches for stormwater capture, that identified some of the opportunities and barriers. And very, very briefly, we found that not only are there technical barriers that can be overcome, but there are public acceptability issues that have to be overcome and have not yet been satisfactorily addressed. We pointed out some of the ways that could be done. Options for funding and partnering with private sector groups to do this well, to address questions regarding the risks to public health from stormwater, and to identify successful applications. Recently, we had a conference on groundwater management here in California that brought in experts from the European Union who have been grappling with this issue for many years, and people here in California who have recently begun to address it as a result of the Sustainable Groundwater Management Act. This is a classic example of how we like to work a problem. We brought in experts from basically throughout the world, convened them for a couple days, synthesized and distilled their conversation, and then are in the process of putting out a report, which will be posted on our website soon. And we're going to have this event recurring here as more implementation of our Sustainable Groundwater Management Act occurs, and as there are new lessons to be distilled and learned by Californians. Conservation. Some of you might remember during the heart of our drought here in California how some people took it upon themselves to try to be neighborhood activists and encourage people to stop watering their lawns and to water their foliage in a modest manner. This particular young man, Tony Corcoran, spent his days taking pictures on his smartphone and putting them on the web. And we sometimes call this shaming or outing, which may have a cathartic effect. It may make you feel good to embarrass your wasteful neighbor, but in fact, it does not work to encourage conservation, but it can earn you the privilege of getting soaked by someone's hose as they're watering their lawn, as happened to Tony. A better way is conservation through partnering, and we work, as you can see in these pictures, with our local water agencies, including Irvine Ranch Water District, and having workshops on what you and I can do in our homes and in our yards and in our gardens to conserve water. The idea here is that most of us would like to do the right thing if we knew how to do it. And if we knew that there were ways of doing it that were economical and fair and sensible and aesthetically pleasing. So again, partnering with water agencies to encourage conservation, something very critical. We have been involved with global partners in Australia, where we looked at low-impact developments, stormwater harvesting, and so forth, and actually produced a book that I edited that actually involved a number of people from Australia and Southern California looking at water innovations. We have worked with a group called Network H2O, which is a group of cities within the European Union who are looking at ways of creatively managing water in producing an urban water atlas, and also a conference encouraging cities throughout Europe to look at ways of better managing water in the future. We recently worked with some people in Mexico and are continuing to work with the Mexican government on reforms in water law. We'll have more to talk about that later in the year as that matriculates. And recently, we've been collaborating with some scholars at Tel Aviv University in Israel and at the Arava Institute in the Negev Desert. And last major subject, very briefly, global engagement and the demise of inland seas. Not surprisingly, the Salton Sea is again in the news here in California. Some of you have been reading about it. One of the things that we find very intriguing is that many of the problems we have here in California and in the Southwest resonate throughout the world. We have an inland sea that is shrinking and is posing public health and environmental problems. And it turns out that in the Middle East, there are actually several endangered inland seas, but one is the Dead Sea, which is shared by Israel, Palestine, and Jordan. And when you look at the impacts, they're actually quite comparable to water supply, ecology, and tourism in Israel, Jordan, and Palestine, in the case of the shrinking Dead Sea. And in terms of solutions, an engineering solution has been proposed between Jordan and Israel to divert water from the Red Sea and put it into the Dead Sea, and to also create a desalination plant which will provide water to Amman, Jordan. This is proposed as a solution to restore the Dead Sea. But right now, its status is stalled, not surprisingly, because Israel and Jordan, the current leaders pictured here on the bottom of this page, are unable, King Abdullah and Prime Minister or outgoing Prime Minister or ingoing again Prime Minister Netanyahu, we don't know exactly the status of that, agreed to build a canal, but in fact, it stalled because negotiations over managing water rights between Jordan and Palestine and Israel are quite at an impasse. In the Salton Sea, we have adverse impacts to citizens in that region due to air quality being dust pollution, and it's injurious to people in Southern California as well as in northern Mexico. Again, there is a diversion project that's been proposed between the Sea of Cortez and the Salton Sea to restore this. And very similar to that situation in Israel, Palestine, and Jordan, there's been no formal negotiations between the U.S. and Mexico that have occurred, largely because of a lot of diplomatic impasses on other issues. The point is we are working with our colleagues in Israel to see if there aren't ways of exploring these issues and bringing us together and helping our students, as well as our faculty, through international visits. Our students going over to the Negev Desert and the Dead Sea, their students coming over here to the Salton Sea and the Borrego Desert to see what lessons can be learned that will be useful. Final note on this, politicians cannot agree on much of anything. The good news is scientists in all three of these polities, in the case of the Middle East, Israel, Jordan, and Palestine, are working together on collaborating and studying these issues, which suggests that science communication can take place even when political communication is not optimal. So a water resilient future requires synthesizing, distilling, and teaching water science, appreciating the human dimensions of water, something that previous inhabitants of our region understood because they observed nature and they respected its limits, suggesting that maybe we need to go back to a future when Native Americans in this region appreciated better than we apparently do now the need to do some good things. So with that, I want to thank you very much for your attention. I want to introduce our first formal speaker for today, John Christensen, who is a professor at UCLA. His presentation is entitled 3 Secrets of Successful Strategic Environmental Communication. John is the founder of the Laboratory of Environmental Narrative Strategies at UCLA and a science writer and environmental journalist. He's going to share 3 secrets of communication. They are empathy, narrative, and strategy. And he's going to talk about how these secrets work and why they work, and give us some tools to put them to immediate use. Please welcome John Christensen.
I'm going to step back some from the immediate discussion of water and all of the really interesting challenges and conundrums here and elsewhere that David talked about, and try to give you all 3 secret tools for successful strategic environmental communications. This is a course I teach at UCLA to environmental science students in our interdisciplinary program in the Institute of the Environment and Sustainability, as well as students from across campus, and it takes place over 10 weeks and a quarter, and I'm going to try to do it in 50 minutes or less this morning. I'll be interested to get your feedback on how that goes. How many of you know who this guy is? Anybody? Ram Ramanathan from Scripps, very good. And how about this guy? He's a little more recognizable, right? What's his name? Francis. So Ram Ramanathan is a scientist at the Scripps Institute at UC San Diego, just down the road. And his national origin was Indian. He grew up in India, studied in India, came to the United States as a postdoc and then worked as a scientist and was one of the discoverers of the global warming properties of chlorofluorocarbons. Really important discovery in understanding climate change. He's gone on to work on black carbon and its effects on global warming in India and over the Indian Ocean and elsewhere. And he became the head of the Vatican's Academy of Science, first under the previous Pope Benedict and then under Pope Francis. And they wanted to, the Vatican wanted to hold a conference with the Academy of Sciences that they were going to call the sustainability of nature. And they decided that, well, they should really put this together with the Academy of Social Sciences in the Vatican. And so they, because it takes humans and nature, right, as all of us, together. And they were going to call that, so they decided to call it the sustainability of nature and the sustainability of humanity. Put the two together. And then they wanted to add one final phrase to it, say the sustainability of nature and the sustainability of humanity, our responsibility. And Ram thought, that's weird. Like in science, like we talk about all these things, but we never talk about our responsibility. Interesting. So they had this conference, and at the end of it, traditionally there's a audience with the Pope, and the advisor, the chancellor of the Academy, Marcelo Sanchez Sorondo, who is just standing behind the Pope, you can't see him in this picture, said, at this audience, he told Ram, you're going to be able to tell the Pope 3 things. And so I want you all to keep that in mind, because I want to ask you about your work, your research, your teaching. If you were able to tell someone 3 things about what you do who could really influence in a positive way what you do, what would those 3 things be? So remember that, and we'll come back to it. And so, Ram had in his imagination, he thought, well, they were going to be in the Grand Basilica, St. Peter's, all this gold ornate stuff for this audience with the Pope. And they go out at the end of the meeting, this meeting on the sustainability of nature and of humanity. And they're on their way over to the Vatican to meet with the Pope, and they get out of their bus and their van, and they're standing around the parking lot, and this little Fiat pulls up. And the Pope jumps out. And, and they said, okay, Ram, here's your chance. What 3 things would you tell the Pope? You're standing in the parking lot or on an elevator or in a reception, and all of a sudden you can tell your story. What's it going to be? So I want to leave you there, and we'll come back to that. And I want to try to give you something of these, what I think are the 3 secret tools for successful strategic environmental communication, and that we will see that Ram used in a way. He might not have thought about them in this way, but he used them intuitively. And those are empathy, narrative, and strategy. So why is empathy important? And this is going to be interactive because as someone who communicates, I think that communication starts with listening. So you can't sit back. I'm going to ask you to contribute some things, as we already have. Why is empathy important?
Know your audience.
Know your audience. The great line that we all learn and is very true. Any other?
It helps you connect how much you know until they know how much you care.
That's a very, very good way of putting it. Say that again?
People don't care how much you know until they know how much you care.
People don't care how much you know until they know how much you care. That's really a beautiful way of saying it. Was there someone else had a? Yes?
I would say it gives you an opportunity to connect.
It's a connection. It gives you an opportunity to connection. Empathy is actually a connection. It's What is one popular way of talking about empathy? What is empathy?
If you understand where the other person's, like, you demonstrate that you understand where the person's coming from or how they feel.
Showing empathy is showing that you understand where someone else is coming from. Empathy is the practice of putting yourself in someone else's shoes, trying to understand the world from their perspective. We know from science communication research and climate change communications research that one of the major reasons why communication fails is the lack of empathy, the lack of understanding your audience. And there's plenty of research on this. I've spent a lot of time, I worked with Ram on a report called Bending the Curve, 10 Scalable Solutions for Carbon Neutrality and Climate Stability that would involve 50 scientists from around the UC system. And so one of our teams studied science communications. We know a lot of ways in which science communication fails. And we're hoping to learn more about how to be successful about it. One of the reasons it fails is the lack of empathy. I want to recommend this book. I use it in my class. And there's an exercise in here that I ask my students to do that I would highly recommend it to you. It's sort of at the center of the book where Alan Alda, and this is a wonderful, fun book, easy to read about, but it has a lot of science in it. He does this experiment where he gets set up with like some brainwave stuff and does in the computer and everything, and he has an app, but you can do this in a very simple way, which is what I ask my students to do, which is just to carry around a little piece of paper. Just do it for one day, and every time you have an interaction with a person that is more than 10 seconds long, could be just 15 seconds long, just to yourself, try to name what you think that person is feeling. And you don't have to talk about it with them, you don't have to see if you're right or anything, but just, after you're done with it, just jot it down on the piece of paper. And then I ask my students to write a short paper about that experience, to do this with at least 10 different people, and then write a short story or essay about this experience. And what Alan Alda finds, through the scientific experiment, I think a lot of my students also find, is that you can practice empathy. You can get better at it by exercising that capacity in yourself. And it's a very simple thing like that, by just taking a moment to notice and name it. So why is that important? In the science communications literature, it's framed this way, that it's important to understand other people's frames, narratives, and values. So the frames are the way that we see the world, the way we kind of frame up the world, the lenses through which we see the world. Narratives, the stories that we tell about ourselves and the world, and our values. What matters to us and what do we care about? And if you think about it, all of these things are important to you and that they're different from your friends, maybe even some of your family members who you might have a little trouble talking about certain things over Thanksgiving or whatever it might be. And we know that this is important because of that research on climate change that David showed. Those partisan differences are incredibly stable, unfortunately, over time, as research from Yale and George Mason climate communication centers have shown, because they have to do with these things. And those things, the frames, narratives, and values add up to your identity. And identity is super important and very stable and hard to change. And if you don't understand it and don't address it, there's no way you're going to be able to communicate with people who think differently from you, see the world differently from you, tell different stories about the, about the world. So, and there is some intriguing evidence that if you do these things, and another piece of bit of evidence that if you invoke people's curiosity, you can get a lot farther. We know that you can try to fill people's heads with as many facts as you want, and it doesn't change. It often doesn't change and often reinforces people's beliefs because it's very easy to incorporate new facts into our existing frames, narratives, and values. So understanding those, understanding how to tell stories that then engage people, meet people where they are, and invoke their curiosity about the world, that can make a difference. So what is a narrative? The second tool. A story. Yes. It's a sequence of events. It's a story. It often has some common elements of it. Many of you are teachers. So I want to show you 6 easy-to-use narrative structures to keep in your communications toolkit. The essay, the narrative, will quickly go over the modular, I just touch on that, IMRET ABT message box. Okay, so this is something, as I tell my students, that I know you've kind of been taught, like you've come to hate this thing. What's it called? The 5-paragraph essay, and we all think, oh my God, I would have to write one again, and like, did you learn that? You learned that in school. What's the first part of it? Introduction, or what's another word for it? Thesis. And then 2, 3, and 4 are your body paragraphs, and 5 is conclusion. And your body paragraphs have, a topic sentence and an argument and some evidence for it, and they all lead to a conclusion, and you're all going, oh my God, this is the most boring thing in the world. What is this guy doing saying this? The reason I want to do this is because to show you that there's some very basic structures and there's some parallels between them which give them power. That speak to us, that are easy to use and easy to understand, and that have real power in them, and that even when we come to kind of get tired of them, to come back and reinvigorate them with some energy. So I want to show you the parallels here between one of the most powerful forms of communications that humans have, storytelling, narrative. What's the first part of a story? What's that? A hook? Yeah, you could call it a hook. What is it that hooks us? An inciting incident? Speak up. Characters are important. There's a character. What happens in the inciting incident? A problem. A problem that has to be solved. So and sometimes we use it, in the sort of technical jargon of this, we use a different word for this. We can call it a complication. And a complication that needs to be resolved. What comes in the middle? Discovery, stories, sometimes there's setbacks, there's what we might just call these generally is just plot development. Stuff happens. But it leads, and you can get more complicated than this. Often the fourth one is, you come to you have an inciting incident that is reveals the complication, and the fourth part you might have, development to a point of insight about what the resolution needs to be. And that's really kind of the climax. And after that, you see the resolution, and it's what the fancy French word is denouement, of the resolution. So you all know this pattern, right? There's a young boy on an arid desert planet, scavenging things out in the countryside, and he comes across a little robot that he brings back to the family workshop, and they dust it off and they turn it on, and what happens? What happens? What happens when they turn on the robot? Speak up, I heard it. Help me, Obi-Wan, you're my only hope. That's the complication, and we're off to the races, and all this different stuff happens, and he realizes his power, and they unite with Princess Leia, and they get the schematics to the Death Star, and using the engineering as well as his Jedi faith, they blow up the Death Star. And that's, the resolution, at least for that one. But what we have in that form is the old form of the epic, which is narratives within narratives. But that's one that we have. And I want to argue for you and for your students that do you see the parallel here? So if you can make your essay have the power of narrative, that it has not just a thesis or an introduction, but it has a complication, a problem that needs to be explored and understood to come to a resolution instead of a conclusion, that then your essay even has that power of narrative, and that each of us, every day, we're taking steps to resolve complications in our lives, and that you can do the same kind of exercise with empathy you can do with narrative. I once did a series of stories for a newspaper in Nevada called A Day in the Life of Nevadans at the Millennium, in which I followed around a high school student, a cop, a doctor, the governor, a rancher. And the premise was, or the hypothesis was, that if I convinced them to let me come as soon as they got out of bed, or as soon after that as they were, willing, and to stay with them. I wouldn't tuck them into bed, but to the end of the day, and I didn't do an interview or anything. I just watched and observed that I would see how we're each taking steps in our daily lives to resolve bigger complications. And that I could understand those bigger complications, and it worked. So I think you can do that with your observations of people, with your observations of yourselves, and that's the power of story. Now, who knows what this is? I'm sure some of the scientists in the room know what it is. No? It's what, huh? Thank you. It's the structure of your almost every scientific journal article, and even some in the social sciences: introductions, methods, results, and discussion. Now, can you see the parallel there? Are you still with me? So if your introduction is about the complication, your methods is about how you went about trying to solve that complication, your results demonstrated and your discussion shows the resolution, you've captured the power of narrative in a scientific journal article. There was a study by a guy named Randy Olson who took a bunch of different journal articles and analyzed them this way, but to see whether this IMRAD structure had a narrative to it. and then looked at the citation rates and found that those journal articles that actually have a narrative in this kind of structure are more highly cited than other journal articles. So you can bring that power even into a scientific or social scientific journal article by thinking about that basic thing about complication and resolution. What is the problem and how are you trying to resolve it? Now I want to give you, and that Randy Olson, who was a scientist and then came to Hollywood and written a book called Houston, we have a narrative. I should have put up a picture of his book too. He came up with this very, very simple structure. I mean, he didn't come up with it, he discovered it. And some of my colleagues in the humanities, and rightly so, roll their eyes when I get this simple and try to teach this very simple thing to my students. Because of course the world is more complicated than this, and narratives are more complicated than this, and this, and the beauty of the literature cannot be so simplified. But it is something I want you to keep in mind here, and I want to show you. I want to try to show you some of the power of this. And, but, therefore. Where's the complication? But. The and is the setup, the situation, that leads to the complication, and where's the resolution? Therefore. Okay. Now I'm going to do something, again, that some of my colleagues might think is somewhat sacrilegious, but I think is powerful, so I'd like to share it with you. Oh, this, actually, I'm going to take a little digression here to give you one more book recommendation and one more method recommendation that I promised, since I know you're all kind of interested in this field. This is a book by Nancy Barron, Escape from the Ivory Tower, A Guide to Making Your Science Matter. It's about science communication. And she has a tool called the message box. And this is, all of what I'm sharing with you, these are, this is science and art combined. So you want to think like what tools like really work for you. But she recommends, and you can find this online. I highly recommend her book as well. Can you see where you use this? You use this blank box, and you just write in here, what's the issue? Is it that recycled water in Los Angeles, in contrast to Orange County, got tagged with this horrible moniker of toilet to tap. It derailed it for years. We need to figure out how to tell a story that can be part of communicating to solve that problem, because we need to use recycled water. That's going to be an important part of the future. So what's the issue? You write in what are the problems, what are the solutions, who benefits or what benefits, not just people, but ecosystems and others. And so what? Why does it matter? Well, because it matters because of those trend lines of water on the Colorado River, snowpack in the Sierra. We need to, and the point here is to distill it down to like one or two sentences or phrases in each box, so you really get it down to that. And then I think you can go back then to the narrative or the ABT. So, whoops, what did I do? I pressed the wrong button. Can you bring me back up? Hello? Oh dear. Oh, I think he's there. Sorry about that. So I'm going to go back to the and, but, therefore. You with me? It's short. If you can distill your message down like this, it can be very powerful. 87 years ago, our fathers brought forth on this continent a new nation, conceived in liberty and dedicated to the proposition that all men are created equal. Now we are engaged in a great civil war, testing whether that nation or any nation, so conceived and so dedicated, can long endure. We are met on a great battlefield of that war. We have come to dedicate a portion of that field as a final resting place for those who here gave their lives that that nation might live. It is altogether fitting and proper that we should do this. But in a larger sense, we cannot dedicate, we cannot consecrate, we cannot hallow this ground. The brave men, living and dead, who struggled here have consecrated it far above our poor power to add or detract. The world will little note nor long remember what we say here, but it can never forget what they did here. It is for us, the living, rather, to be dedicated here to the unfinished work which they who fought here have thus far so nobly advanced. It is rather for us to be here dedicated to the great task remaining before us, that from these honored dead, we take increased devotion to that cause for which they gave the last full measure of devotion, that we here highly resolve that these dead shall not have died in vain, that this nation, under God, shall have a new birth of freedom, and that government of the people, by the people, for the people, shall not perish from the earth. So what is this? What was the occasion? What, sorry?
Dedication of a cemetery.
The dedication of the ceremony. Who's speaking? Abe Lincoln. One of the most important, powerful speeches in American history. Indeed, was remembered, it has lasted. And it may be somewhat, as I said, sacrilegious to do this, but I think it's important and an important, powerful kind of lesson. Where's the and? The first two paragraphs, did someone say? 87 years ago, the founding, and now we are engaged in this great civil war, testing the propositions of the founding, and we've come here to dedicate a portion of that field. And the but? It's right there. But in a larger sense, we cannot dedicate, we cannot consecrate this cemetery. It's far above us to do that. They've already given their lives to do that. It is already hallowed ground. Therefore, there's no therefore, but there is a rather, which is a good. It is for us, the living, to be dedicated to that great task remaining before us, that great task that is still remaining before us as a nation. So I want to now turn to the last tool, strategy. And how do we develop a strategy? Because I think if you can put these three together, you have really powerful toolkit for communications, no matter what that field is. Who knows what this is? A logic model. How many of you have seen one of these things before? All right. What is another name for a logic model? A theory of change. These are, and you can find these, you can find a blank template for these, you can find different versions of these online. It's called a logic model or a theory of change. And the theory of change is, how do you get to the impacts? How do you get to the outcomes and the impacts that you want in the world? That's your theory of change. That's your story of how you're going to get there. It's called the logic model because it's asking you to test every step along the way and make sure it fits and that you don't have any magical thinking in there like, if we build it, they will come. Do you want to, how are you going to market it? How are you going to encourage people to come and, come to your event or do the things that you're asking them to do, or to support the tax measure that is going to fund groundwater capture and to the tune of $300 million a year in Los Angeles County, for example. So, and when we do this, we always start at this end with the impact that we want to have in the world, and we work backwards. What are the outcomes that we want to that we need to see in order to have that impact? And I want to give, and again, there's an art and a science mixed up in here. So these, they're but what these are tools to think with. The empathy, understanding, the narratives, this kind of framework are tools to think with. So I want to give you an example of, well, let's instead, who wants to share with me a project you're working on and what you hope is going to come out of it, the outcome or the impacts? Does anybody have one? Either something that you're working on here in the Institute, or you're in your teaching, or don't be shy.
So I'm a water conservation consultant.
Thank you.
And just became an adjunct professor at Santa Monica College to develop.
Congratulations.
Thank you very much. So this is very apropos. But one of the things I developed was a toolkit for water agencies, small, medium-sized. It has everything they would need to start and implement water conservation programs. So it has everything you need to do, rebates, marketing. And so I just developed it, and now I'm ready to share it with the world.
Perfect. So she's developed, did everybody hear that? She's developed a toolkit for water conservation for agencies in all kinds of cities, or small cities and big cities. And she, that has all the sort of tools that they can use to encourage people to conserve water. Now, what is she going to do with it? So tell me, what is the impact that you want to see in the world?
I'd love to see that with this toolkit, end users actually reduce water and for long-term water savings.
Okay, so she'd like to see end users actually reducing their water. Now, here's where the art comes in. Is that an outcome or an impact? What's the impact that you'd actually is reduce water use? And I push you a little bit further and say, once reduced, what is the impact of that reduced water use?
Resiliency.
Okay, was there something else?
Yeah, I was echoing that.
Resiliency.
Value of water.
The value of water is recognized, or
not lead to the shortages into drought conditions.
there may be fewer shortages. I would also maybe add there's more water for ecosystems. There's more water, yeah. So again, you see, you want to think a little bit of that. What is that difference between impact and outcomes? What are the outcomes that you want to see, but what's the impact? I think you want to see healthy, thriving communities in arid ecosystems, right? Or something like that. And it can be that grand, you can get grand about the impact that you want to see in the world, but then get very specific about the outcomes that you want to see in the world. Let me give you an example. If I were running a vaccination campaign in Brazil, for example, and I wanted to vaccinate, 50,000 kids against common, fatal childhood diseases. And I put together a program to do that. What is the impact? And say I'm successful. What is the impact? Speak up. Reduce childhood mortality. But what if I said heard somebody else say longer lives? Healthier, huh?
Healthier lives.
Healthier, longer, healthier lives, happier. Their communities are better. So the outcome might be would be hopefully reduced mortality, but the impact would be healthier lives and communities. Do you see what I'm saying? And this is an art, so you can argue over it. The long term would be longer lives, reduced mortality. Let's say the longer lives. Maybe this is reduced mortality. I actually get 50,000 kids immunized, and over the course of this program, or over a year. The outputs, now I want to go back to what are the outputs that I need? Well, I need to send doctors. I need to have vaccination clinics. I need to make sure that, there's things on the radio, there's things in the newspapers, that people read about it, that they come to it. And you always want to think of these outputs as not just things that you do, but who participates in them. Because if you're just doing them, again, you just can't. That's the magical thing. If we just build it, they will come. I want to send 10 doctors to 50 different villages and sponsor 100 different clinics, and I want 5,000. I want 25,000 parents to participate in these things. So thinking very specifically about, what are you going to put out in the world? What kind of activities and what sort of participation are you going to get, so that you think really carefully about that. And then you back your way to what are the resources and inputs that you need? You need funding, you need vaccines, you need doctors' time, you need teachers' time, you need nurses' time. Those are all the resources and inputs you need. And then you want to do a little bit of thinking about the situation. So what are your... you have some assumptions that if you do this, that things will turn out right, that the planes will go on time and all of that, and that, the weather will be okay, and that, people will understand the importance of getting their kids vaccinated, participate in this. So these are all some of your assumptions that you want to get clear about. And then the external factors. So what is something that could happen that you have no control over, that might affect your strategic plan here? Cultural skepticism could be one. I think that's also partly in the assumptions, right? You're assuming that you're not going to do this. You're not going to encounter that you'll be able to overcome it. What? A natural disaster, a war, or Jair Bolsonaro gets elected president, and or somebody else I won't mention today, but So you want to think about those things, just be aware of them, that they're out there and they could affect what your strategy is. So I want to argue, if you put these things together, this is one that I share with my students, particularly for those of you who are interested in communicating in policy. What do policymakers want from you? They want things that are timely, responsive, clear, actionable, local, and confident, that you give them what they need when they want it, you're responsive to them, you're clear and concise, that you give them actionable information, that, things that they can put to use and act on it, that it's local. All politicians in Orange County really do care about Orange County, and that you're confident about that. That you are confident about the work that you present. This, I just wanted to give you a few examples of work that we've done in this vein that tries to combine all of these elements and focusing on changing narratives about funding for environment in California, to the importance of having real priorities, measurable priorities for investing in disadvantaged communities that have not historically been invested in, and that when you have those clear priorities, they're stated in the law and they're carried through implementation, that they really work, compared to when you just list it among one of many priorities. Work that we did on the new challenges to coastal access, not just on the last 100 yards to the beach, but how finding, through surveys and a public opinion poll, that the cost of getting to the coast is really getting out of reach for about half of Californians in their everyday lives. And so we work with funders and advocates and policymakers, to have a conversation. And this is where these things are focused on. I hope you can tell there's a strategy here. There's a story. So it's about changing the narrative. And there's an important work of empathy, of understanding the audience here, so that this work is always done in conversation with advocates, with policymakers, so that we understand the audience and their frames, narratives, and values. That I always say, I will make sure that the research that we do, the social science research and other research that we do, is defensible, is robust, is objective. You won't push me off of that, but I want you to push me as hard as you can about how to best communicate it so that it's useful. Because I know I hope I know some of what I don't know, and can learn from working with community-based organizations, with advocates, with policymakers around the state. We recently did one that was kind of a follow-up to the Prop 84, looking at implementation of Prop 1, the big water bond, halfway through, and continuing to tell that story, but the importance here of technical assistance and of really what I've come to sort of see as technical assistance, kind of community organizing in some cases, where you have a water system in the Salinas Valley or the Central Valley that is run by 5 people, and the receipts and notes from the corporation are in a shoebox in someone's closet. And that figuring out how to, ensure that the human right to water, which is enshrined in law in California, is actually realized in a state where 1 million people still do not have access to clean, safe, reliable drinking water, involves the importance of this community organizing, of technical assistance, of meeting people where they are, if finding out what they need and want for their communities. And we recently did this other study for California State Parks of changing the way that we look at parks, and particular the communities, park poor communities that most need them. So instead of looking just at what parks are available in a community, what community is available to a park, and how to reach those audiences that could most benefit from what we know are the health and mental health benefits of access to nature and the outdoors. So I just wanted to show you those as a like kind of little taste of how we think about trying to put together those three things: empathy, narrative, and strategy. And then I wanted to leave you back in the parking lot with Ram and the Pope. And you have three things. You're told you have three things you can say to the Pope. What are they? Ram said, "We are members of your academy. We are here on your behalf, and we are all worried about climate change." So what's going on here? Empathy? Did I hear empathy? Yeah. We are members of your academy. We are here on your behalf, and we are all worried about climate change. He knew, is that know your audience, relate to your audience, show, as you mentioned, show through what you say and how you pay attention that you're listening and you know your audience. Most of the pollution comes from the wealthy 1 billion on the planet, whereas the poorest 3 billion are going to suffer the worst consequences. What's going on there? If we apply the ABT here, which one's, Where's the but? Whereas, which could also be but, yes, exactly. And again, there's a lot of empathy in that sentence as well, because he knows that the Pope cares about everybody, right? And all living beings and creation, but the Pope really cares about the poorest 3 billion on the planet. And so, what's that?
Giving numbers, demographic.
Yeah. So then the guy behind the Pope, the Chancellor, Miguel Sanchez Sorondo, says, tell him what he should do. The Pope wants to know what he should do. So he said, you're so well known in your speeches, if you say people should be better stewards of the planet, that will be enough. And so what is that? Therefore, here's the complication, here's the resolution. You're empathetic to your audience as the agent of the story, the agency that they can take as a character in this story to inspire them to be those agents, that there's a story that makes sense for them within their frames, narratives, and values. And so a couple weeks after this, the Pope met with his staff in the Vatican, and they began work on the encyclical that came to be known as Laudato Si, Care for Our Common Home, which was the Pope's encyclical on climate change, which when I met with Rami, he told me that he thought that had been done more to move the narrative, move the story, move the conversation about climate change than all the work that scientists had done, and which is not to say that the science is not important. It is very, very important, and he would emphasize this too. And that would be the final short book recommendation I would leave with you. If you ever, have a couple of hours on a weekend and download Laudato Si from the web and read it, I think it's one of the most important documents, books, short book. You can read it in a couple hours in what we call the environmental humanities today. And I think you will see the ways in which it is the things that I've been talking about at work, the empathy, the frames, narratives, and values of the Pope, some of which you may not agree with. I don't agree with all of them, but and then also that strategy, which I hope you can also see here, that that the strategic thinking that was in here as Ram told this very, very short story to the Pope. And again, I would ask you all to think about what are the three things that you would say in the form of a strategic story to someone who's important in your lives, in your careers, in your work. It doesn't have to be the Pope or a governor or anything like that, but to think about that and to be ready, because if you're ready, there can be these opportunities, and if you think about that story and know that story, it will be in you. Because as Brahm said, as soon as the Pope got out of that little fiat, his mind went blank. He'd prepared everything he wanted to say, but his mind went blank. But when you've thought about it and you've integrated that, into your thinking, you'll find it's there. So thank you.
Just time for a question.
We can do one question, sure.
One question.
Yeah.
I appreciate everything that you shared with us, and as an educator sitting here trying to think of what I already do or what I need to do differently. I've been concerned over the last couple of years with authenticity, and you're asking scientists, not you, we need to be authentic in our communication, we need to be empathetic, we need to do our best to communicate to perhaps non-scientific minds. And so we're being very authentic. And sometimes we're having to deal with a lack of authenticity on the part of the recipient of the information. And that lack of authenticity might come back with a response, something like, yeah, but, or what about, and some other things where we've done everything we can to communicate, even given the parameters you suggested, and yet there might be something that's causing a block that we might need to address. And I think, I personally believe, as an educator and a communicator now with other people with some years, that sometimes there's just something on the part of the recipient that they're not able to receive the information.
Yeah, and I think you've, I don't stand up here saying like this is the answer to everything, I think these are tools that you can use to think about those situations and different communications challenges, and that are part of a larger strategy that whether it's scientific or policy or educational that you have, and I don't think and this doesn't mean any of these are like easy answers. They're actually tools for us to think hard about the problems that we have, the stories that we want to tell, the relationships that we want to have with other people, and understanding other people. And so I have a couple. Let me see if I can have like a couple of ways of thinking about that. One is that if you look at the polling data from the Yale and George Mason centers on climate communication, where I described how those partisan identity issues, the problem with like climate change and even the environment in America has become polarized, and it's become a marker of identity rather than the thing itself. So that the way that people talk about and think about environment or climate change is within those frames, narratives, and values. And so it's not something outside of that we can talk about in a way, with, objectively or, without invoking now all these political identity questions, that come with it. So it makes it very, very difficult and unfortunate, because that was not true, in the 1970s when most of our major environmental legislation was passed under President Nixon, for example. So, now we have to figure out a way out of that history. And I don't have an easy answer to it, and it's a big challenge. But if you look at those, they have something that they call the Six Americas. And on the one hand, are people, like maybe, a good deal of this audience that are alarmed about climate change. And, think that's something we ought to, we really need to do. And then there are people who are concerned, there are people who are paying attention, and then there are people who we call, the denialists, who say that, it's not caused by humans, it's not a problem, whatever you want to say about that. That's about, this is a different talk, so I don't have those figures. That's about 7% of the people. If you take out the alarmed and the denialists, there's 75% of the American public that I think are persuadable. I sort of think, like with the denialists, my own view, this might be controversial, it's like, don't waste your time. Like, why would we, when 75% of the population is persuadable, including, I think, and this might be a little bit controversial too, are the skeptics. I sort of think skepticism is like part of what we do as academics or researchers or scientists or teachers, trying to teach people to think critically. And so, I think it's worth talking to skeptics and spending time with them. And there's some intriguing stuff in the literature, and the literature on science communication is it's a work in progress, honestly. And it's social science research, which, if you have a R square of 20 or 30, sorry, getting technical, but if there's some correlation, you're lucky if you could. So I think this is really good, important research. There's a lot of interesting stuff in it, but it's also, there's a lot of contradictory stuff, frankly, as well. But there is some intriguing work that if you bring people into the story of science and to, the discovery, but also I think also the skepticism and the doubt and the uncertainty, that you can bring people along in a way that you can't just by giving them the results and the facts. That you change more people's minds by bringing them in to that story than by just giving them the results. And I don't think we do that enough. I think we're scared of talking about uncertainty, for example, because sometimes it can get misused, and I understand that. Let me just give you one final example. So I got a call from an AP reporter. I was doing a story in Nebraska about how there's a bill in the legislature to fund the University of Nebraska, like the University of California, one of our great land grant institutions in the United States, to set up a center for understanding climate adaptation in, one of the regions of the country that is the grain belt and, producing a ton of, food and, and really in need of understanding, not only how to reduce carbon emissions and to mitigate, but also to adapt to the changes that are going to come. And it was very, I can't remember the exact figures, but it was fairly low cost, to do a climate adaptation plan for Nebraska. And the Nebraska legislature defeated it. And it was kind of clear it was going to be defeated. So the AP reporter was calling, saying, why do we have such a problem talking about this? And I talked through a lot of this stuff and said, well, maybe if you talked about, if instead of talking about climate, you talk about, precipitation, drought, crop productivity, that you would be meeting you would be meeting the people who are influential in the Nebraska legislature where they are, and I'm not like that's not a panacea, but I think if that we're badly in need of being able to change those conversations to some grounds, where we can have those conversations in Nebraska. I mean, we don't have a problem with having those conversations here in California, but there are places in the country, where the terms of the conversation are going to have to be different because the frames, narratives, and values are different. And if we're going to make progress there, if the University of Nebraska is going to have to make progress, God bless them, they have to figure out how to do that.
Thank you.
All right, thank you so much, John, for the great talk. So our next speaker, Sandra Tsing is quite accomplished. She was recently named by Variety magazine as one of America's 50 most influential comedians. She does work. She has an off-Broadway solo show. She participates on National Public Radio, has her own daily science segment, The Lowdown on Science, which I mentioned earlier is broadcast on over 140 public radio stations across the country. She's also an adjunct professor here at the University of California, Irvine, in 2 departments, so in the School of Arts and in the School of Physical Sciences, where she teaches personal theater and science communication. Please join me in welcoming Sandra Tsing here today. Thank you.
Thank you so much. I'm going right before lunch, so I know that you're kind of like waiting for lunch, but let's see if we can rip through this. Okay, here's my talk. Elucidating a diagnostic paradigm which is focused on utilizing methodologies in regards to detection of proliferative linguistic norms of diminished functionality in contemporary scientific communication. How's that for a title? Talk science now. No. And again, like John's talk, this is based on a 10-week course. So it's going to rip through very quickly, but I'm very happy to be building on some of the themes that he's come up with. So science communication is often thought of as a contradiction in terms. Why? I'm going to tell you a joke that was told to me a long time ago, and it was about a he, so we can laugh at the he, and then the women can go, that's not about me, but this is the way it was told to me. So do you know the difference between an introverted mathematician versus an extroverted mathematician? Okay. You've been okay. When an introverted mathematician talks to you, he looks down at his shoes. When an extroverted mathematician talks to you, he looks down at your shoes. Okay. All right. And if you don't like that, there are only more coming. So get ready. So, and I think partly, and that's a little bit of a laugh, and that is not true at all. I've actually found scientists excellent at learning how to communicate, and rhetoric, they can do really well with that. But some of the science values of the science institution are themselves not necessarily harmonious with communication. So the culture of academic publishing in science is kind of like the use of terminology unique to one's field with ever-narrowing specializations. There can be linguistic peculiarities of academic writing, like use of the passive voice, which itself is like a 6-hour-long, probably pretty boring talk, but we could do that all day long. Publish or perish, small results merit a paper, and care taken not to extrapolate outward to really large conclusions. And communicatively, that's not maybe the best thing, but as scientists, we could say that's not a bad thing, because as opposed to politicians or others, it's good that scientists don't extrapolate breezily outward, that they're a little bit cautious, a little bit wary, a little bit worried. Like Tom Mueller, the SpaceX propulsion chief, he has this great saying, there are a thousand things that can happen when you go light a rocket engine, and only one of them is good. So we want scientists to be cautious and not promise the moon. Just a moment, I'm going to talk about my dad for just a brief nanosecond. He died semi-recently at 97 years old. He was from Shanghai, and in a way, and I went to Caltech. I got a BS in physics. I really put the BS in physics when I graduated in 1983. But I kind of got used to his way of looking at science, and it was really old school Caltech stuff. And I do have an Asian dad meme from the interweb. Would you like to see it? Yes. Would you like to see it? Okay, good. Thank you. Here it is. Okay. Please enjoy. You got hepatitis B? Why not hepatitis A plus? Thank you. I'll be here all week. Okay. No. Okay. But his way of he didn't understand. Classic Shanghainese engineer, that after dinner, he'd always bring out the computer paper with the holes in the side and have math problems that I would have to solve because I was the youngest and didn't run away quickly enough. And he would always be so excited, like a cat chasing a mouse and drawing diagrams, and then the mechanical pencil would fly faster and faster. And I remember one time at the end, he goes, so is the electrical charge positive or negative? And I knew with my impeded math skills that I was about 50% likely to get it right. And I would go, negative? And he'd go, no, and he'd fly into a rage, funny story, rage, because he couldn't actually understand what it felt like not to understand. He thought I was just kind of trying to make him angry because he could not follow my thought process and I couldn't follow his. It's kind of like a native French speaker trying to teach people to speak French, and so they have it sort of emblazoned or ingrained in their body, and the learner does not. And then also there was kind of the world of scientific colloquia that my dad was really a part of at Caltech, and it would be kind of like scientists going to I'm a Lutheran, so I can't really speak freely of other religions, but it was kind of like old Jewish men going to temple and hearing something in a different language, and you might not understand every word, but you go there to show up and witness. In my dad's case, to have donuts and coffee afterwards. So it was not necessarily important to understand. In fact, there was a bit of a hazing thing that if you could lose the most people in your talk, you would be the smartest. There still is a little bit of that culture extant today. But of course, as we're here with water, it's so important now. This goes beyond culture or ego or anything, because as we know, again with the name who shall not be mentioned, but with climate science today, it's a pressing issue, and as John said, it's very identity based and polarizing. To the point where even the new language of climate change, like don't use the phrase climate change. You call it, climate extremes, precipitation, etc. So that these issues are really important now in scientific communication, and it's time to change the paradigm. So the paradigm shift is from science to science communication, which is a total flip from just being a researcher with a captive audience to a science advocate whose audiences can walk or click away. And I know because I host my daily 90-second science show, and we have to open with a hook or a question because they can totally click away. I mean, they're free to go to anywhere on the dial. So you have to kind of get there in media. You have to get their attention immediately, and we'll talk about how to do that. So, and I really like when I was listening to John talking about curiosity and the mind, if that's the way to get people. And Feynman, who was a fantastic science communicator, as well as a Nobel Prize winner, obviously, he said, I can't do his accent exactly, so I won't try, but you can people lose a lot of pleasure who find science dull. One of the things that makes it very difficult is it takes a lot of imagination. It's very hard to imagine all the crazy things that things really are like. It's hard to picture in your head some of the processes that you are talking about in science. And so, hence, it is your job as communicators to stimulate the imagination of your listeners and to keep them involved. So, part one titles. This is a little bit of a pre-lunch walkthrough stuff that may look familiar to you as practicing scientists, but let's go back to the nuts and bolts of what we actually see. So this is, I just like that because it's from The Fly. And you haven't seen The Fly? watch it again. You know, okay, it's okay. And that's the last plug I'll put for it. Okay, so these are actual science titles from UCI talks. What happens in Beckman stays in Beckman from an AGS symposium a few years ago. So these are, yes, exactly. So these are from actual science grad student talks that are meant for a general public. Here we go. Here we go. Okay. Optical trapping of dielectric nanoparticles by a plasmonically enhanced evanescent wave. Cell type specific tracing of subcortical inputs to B1 from the hypothalamus in mice. Ion transport through manganese oxide mesorods reveals different charge states. Intriguing. Did you know that? Elucidating high resolution, elucidating my favorite word, not, as we'll get it. High resolution structures of amyloid oligomers implicated in Alzheimer's disease. There's something I understood, Alzheimer's disease. Biodegradable anti-inflammatory material. A novel protein conjugated polymer with applications in the implantable medical device field. Intriguing. Okay, so one thing that's interesting is obviously these are hard to understand. And I will teach, 25 grad students at a time in science at UCI. And typically, if somebody is not in the exact field, they will not understand what the title is, what the title means. They would go, I have no idea what that means. Even more intriguing is sometimes people who are in the exact same field don't know what it means. And I think it was true of physics, where I had a couple of physicists that the use of mesorods somehow is not a widely understood term or used term in physics. So they could even be in the same field and not know what the title means. Clearly, Houston, we have a narrative, I guess we would say. We wouldn't call it a problem. And as I like to say, these titles are all cheese grater. Okay, so what do I mean by cheese grater? I think a science talk should be like a cooking show in a certain way. So if I said to you, you know what, let's say 50 years ago, going back in time, I said, you know what? In 50 years, there's going to be cooking shows on TV, shows about people cooking, and they will be so popular, there'll be a Food Network and something channel. You go, no way, that's not possible. People cooking, how dull is that? But of course, we have the lovely Giada, as you know, and then, I start speaking in an bad Italian accent when I'm imitating her, although she does, in fact, not speak with an accent, but we forget. And think of how Gianna would open a show. She'd go, I remember when I was a little girl growing up in Rome, and Christmas would come around, and I remember the kitchen and the dogs running in and out, and the grandfather playing the accordion, and the blah, 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 and the smell coming from the oven of my grandmother's lasagna with this creamy bechamel, et cetera, blah, 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 setting up the issue, the inciting incident, if you will, and then the end of that would be, but she made it with grattugia, which is a cheese grater, and I live in New York City and I don't have one. How can I make grandmother's lasagna here today in New York? So that's the question. And then only then would she go, this is a cheese grater, in the second part. But what do scientists tend to do? They go, this is a cheese grater. It's got nanoparticles and tin and acid, and you go, this is kind of like at least one dinner and a date first before you get to that part of the cheese grater part, because why do I care about this thing? So we open, with the technique rather than the why. So, of course, these are all cheese graters, because it's all the technique. There's a technique. You don't know why, except for Alzheimer's disease. So, let's rewrite a couple of titles. And this is an actual student rewrite. And he then went on to win an AGS prize for money. So this is Movement Anticipation and EEG, Implications for BCI Contingent Therapy. Grab the car keys. I gotta see that talk. Why? What's it about? We don't know. Okay. And you can see a couple of words, anticipation, implications, and contingent. I call these administrator words, and I'm going to cover them in a few minutes as to what these words are and why they slow our brains down so much. Here's his very own rewrite. Are you ready? Brains and robots. Who's really in charge? Is that much better? It is better. Dave, you held the computer. Like you know what they're talking about, and you can run and do that. Okay, here's another one. Clean solar-driven hydrogen production using yellow car paint. At least you kind of have an instinct of the yellow car paint. But isn't this better? Clean air through car paint. Is yellow the new green? You guys didn't get it the first time. Is yellow the new green? Right. So yeah, and so that's pithier and a bit more fun because again, as opposed to the required symposium that people need to go to, where the coffee and donuts are, it's like you would want your title to intrigue people immediately. So I call this the best title structure: the snappy phrase and a whiff of your research, just a whiff to get people intrigued. And I think it goes to what John is saying: curiosity. The mystery, the puzzle is the thing that gets people intrigued no matter what. So the paradigm shift is don't just have your title name your lab research process, use it to cause a question, puzzle, or mystery to fire the audience's curiosity. And I believe a question is completely fine. And it's kind of like, not to have to assert, but like, is yellow the new green? I don't know. And I think there's a longer, yes, if we had another 12 weeks or 10 weeks, it's an inverted structure in a way of hooking people into your story. I like to say, don't open with something like chemical imaging, the cheese grater. Don't open with the tool or the how. Open with curing cancer, the human goal, the lasagna, why. So intrigue them first about what the real world life problem is, and then you can bring the more technical part. Okay, which kind of gets us into part 2, language. I had another fly slide in here, but you can imagine that it was. Okay, there are 3 types of ugly scientific language, and this is what I call, the first is hagfish ugly. It's like, you just see it and you know it's ugly. It leaps off the page, and in this case, the ugly is the hagfish's amyloid blah, 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 oligomers. It kind of looks like a foreign language to people reading it on a symposium board, and sort of they go, I don't know what that is. And so they're easy to, if you absolutely need them, you might, you need this term, then, say, a cure for Alzheimer's disease, blah, 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 oligomers, to make us really intrigued about them. But you have to kind of parse these out very carefully because otherwise they're just terms that will go by. Here's a question for you I like to ask. Scientific terminology. Which field has the worst? Chemistry. Chemistry is often said very immediately, and I love that. We're going to say no, but good one. Anybody else? Physics, good one. No, you know this already. Okay. Okay. So according to Neil deGrasse Tyson, look at that tie. He can really wear a tie. Okay. He says that the best field for scientific terminology is the best one. Astrophysics. The Big Bang, black holes, dark matter, so expressive, so exciting. And for him, he says the worst is geology. Orthoklasfeldspar, mistranslated German. What is that? It's a kind of schist. Say that very carefully, very carefully. Okay. So the second form of ugly scientific language, I just call it standard ugly. It doesn't look as ugly as the amyloid blah, 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 oligomers, but it is problematic nonetheless. Protein conjugated. It seems so friendly, the word protein, like how much is in your cereal, protein, et cetera, et cetera. But this is a kind of language scientists use between each other in their own fields that means something to them, but the audience is not necessarily sure what it means. I had a group of biomedical students, like all spring, they would just say, they would talk to each other in a kind of cool code, like, it's basically just a protein. Oh, that explains a lot. Okay, or it's just a short peptide sequence. Why? How does that help me understand? Or we just need some small molecule. And actually it raises more questions than it answers, like, why not a big molecule? Why not a medium molecule? What is it about the small molecule? So that the audience is wondering after you've gone on to another topic. And I would also famously ask these same students the haunting question. I'll ask you, what is a protein? Just nodding. What's a protein? How do you define a protein? A chain of amino acids. Yeah, so much more clear to people. That really how you do. Say what? It does a job. See, that's very good. It does a job. It's a machine. It makes things as opposed to a carbohydrate that stores energy. So if you're trying to describe it to a person who doesn't have that set of vocabulary, like what is its function within the system that you're describing? But that can be, what is the protein? Try that in your lab today. See if you can make people unhappy. Okay, this is my favorite category, unnecessarily verbose verbs and adjectives. Why do we have these? Life is hard enough already. Okay, so, and here's really my favorite one in the world. Elucidating, implicated. They're administrator words. Like, and the question, why do we use elucidating? Why? Can we stop? The question is kind of a grad student actually at U of Illinois told me that she had put explaining and her professor said, use elucidating. It makes you sound smarter. So she did. So there's words dropped in, but they're long and they're abstract and they don't add to the reader's comprehension, or the listener's comprehension. So here's some sample things of what administrator words I think are: general, abstract, no images evoked, they're multisyllabic, and they have dry sounds, okay? And you'll notice, because I've made quite a study of this, longer than I would like to really recall, that there are not that many Anglo-Saxon sounds in scientific terms, like hard Fs and hard Ks. Yes, a word may have jumped to your mind, and put it away, but it is really, and so that kind of a dry, and I don't know if like sonically or linguistically that has happened to make this administrative sounds and this kind of language. Okay, so here's some classic words that you see a lot of. Are there shorter, simpler words for these? Aggregate, constrain, decreasing, elucidating, exacerbate, increasing, leveraging, perturbated, protective, suppressing, sometimes all in the same sentence. And what happens is the reader starts to kind of go to sleep because then you have the amyloid blah, blah, blah that is elucidating and interspersed with some small protein on it, just like it's like, so it is very hard for your reader to follow image-wise. It's like what Feynman said about the imagination, firing their imagination. For instance, is there a short, maybe one-syllable word for aggregate? Nice. Clump. 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 You know, and it's visual, and you can clump, it hits you as opposed to aggregate, clump. Okay. And I think that in the middle, this would be a longer talk, but we don't have much time. In the middle, sometimes when you get to the cheese grater part, to essence the narrative, you might need to use a metaphor so the person can follow it. And what the short thing that I say, they say about metaphors, and Feynman has some really beautiful ones. If you go online, he talks about the difference between a solid and a liquid in terms of a high school marching band, that solids kind of stay together in formation, and then liquids are just so disparate they fall completely apart. So he liked metaphors a lot. And some people are hesitant about using metaphors because they're not totally exact, but it's not a one-to-one mapping, it just essences the mechanism or relationship that you need to describe your process. This is going to go by so quickly, and I'll give Water these slides so that you can have them. So, you know, there's a lot of different kinds of metaphors: art and culture, shish kebabs for gene splicing, battleships, traffic and travel, war and crime fighting. And the interesting thing about some of these metaphors as they go by, I'm sorry that this is so quick, but it is, that sometimes, like with the Higgs boson, I've seen several different metaphors used to talk about different parts of the Higgs boson, and it just depends on what part you want to essence. And toxoplasma is another example I have that's much longer, where instead of our armies signaling each other, or it could be English grammar, if you're talking about how the toxobacteria virus kind of changes the message that is being sent out. It just kind of depends on what part of the mechanism you're talking about, and a metaphor will do as well. Who is my audience is often asked if you're drafting, let's say, a 3-minute elevator pitch, a 6-minute mini TED, an 18-minute TED Talk, or beyond that involves general audiences. It kind of like, how much information should I put in? And I tend to say reasonably intelligent 10th graders, non-science majors, as denoted by their striped sweaters. As I got off this stock photo off the internet, I go, yeah, it may be kind of prejudicial that these are not scientists, but you know, I could be wrong. And their tennis shoes and their Vans and whatever they're wearing. Okay. So, yeah, exactly. So these listeners have good intuition about daily phenomena, what happens when a car turns hard lefts, that ice melts, how plants need water. Also, unfortunately for us middle-aged people, that carbs can make you fat, as opposed to protein. So you can assume that they, out of things they observe, they're familiar with those kinds of phenomena. They need general reminders about anodes versus cathodes, which is the plus and the minus on the battery. pH numbers, are acidic solutions higher pH or lower pH? You know, if you're dyslexic, you cannot remember that. That's true of me. Or exactly what happened in the Big Bang. When you say the Big Bang, how are you using it? Remind them that it's not just a CBS sitcom, but it, you know, what mechanism you're referencing in the Big Bang, so that you can remind them. And it's a courtesy, because they know something about the Big Bang, then they go, and then what happened? And if you remind them along the way, it makes them feel smart and like they already know something. I tend to use the analogy of, since I teach in art as well, and I've taught English literature, it's just like, you know, if we're talking about Tolstoy and the novel Anna Karenina, and at the end, what happens? How? With a train, right. So that you can remember the ending, and then you can go, something bad happened. What was the one? Was it tuberculosis? And then, like, as we all know, she jumps in front of a train. And so that kind of reminds you and makes us all in the same club in a subtle way, just by referencing what people sort of know, but they may have just forgotten and you haven't put them on the spot. So, and with the level of complexity of a talk, I kind of use the firefighter analogy. Your job is to get your listeners safely in and out of the burning building, meaning, so let's say you had a group of people and you say, let's see what firefighters do. Here's a burning building. Let's go inside and follow the firefighter. Ooh, putting that fire out. Oh, blah, blah, blah. Oh, and here's the kitchen. Oh, here's the toaster oven that started the fire. Wow, we can see how it began. Now get them the hell out of the building immediately before the lumber starts collapsing on them, before they get stuck in a room. You got to get them safely and out, give them champagne on the sidewalk so they'll be ready to do it again. I mean, we all know that with talks, with science talks, where it opens really great with like a New Yorker cartoon, and then how many of us, and they go, and then the first slide, you go, I actually understand that. Second slide, I get that too. The third slide, oh no. Delta what? And then that dreadful fourth slide where they turn back and then they've lost you completely, and then you can never get back again because it was too much detail, and you don't have to redo this experiment in your own lab. You just need to know the essence of it. You don't need to replicate the results. And that's kind of like, and then people, you know, and once they do not understand, they do not come back. Again, with cooking shows, I use the example that as Giada is cooking in the kitchen, you're not cooking along with her, and you may never make that bechamel sauce or whatever that she's making, nor go to Italy, nor anything like that. You're watching it to have the experience of cooking, how that would be a fun thing to do and maybe at some point do in the future. There's no recipe on screen. The recipe will be online, but you're not replicating the results at home. So that gives you a sense of how much detail to include or not in a scientific talk. How much of my research do I need to convey to my audience? And I think you who are, you know, climate scientists and working with the environment, you want to, it's kind of simple. There's just three things. Enough to get them excited about science's ability to solve real world problems. So you don't have to go to the kind of 1 millimeter detail on samples you're connecting, et cetera, but you know, here's the real world problem, the landfill that has toxic fumes coming from it, you know, whatever it is, the real world problem, and then that science has an intriguing solution. And that's always the mystery and the puzzle and the fun of science that makes scientists the heroes, because they're sitting at maybe some part of the periodic table that is going to unlock the mystery to solving grandmother's Alzheimer's, to making water clean, to ending pollution, et cetera, et cetera. So that's kind of that story I think that John was talking about, the essay and the narrative of kind of like, here's the puzzle, here's the mystery, here's the real world problem, and then scientists came up with something and it's called graphene. Yeah, graphene solves everything. So apparently I've learned from some of my students, graphene. And so they'll get excited about this clue. It's like a Nancy Drew mystery or a Hardy Boys back in the day. Okay, enough to enable them to relate a cool new science factoid at dinner mind candy. So this can be, and we certainly work on that on the lowdown on science or in a 90-second. It's like, what is the essence of that people will get out of it? And this show actually started about 15 years ago, my daily Science Minute. And at first, the pieces were 1 minute long, and that was too short. And then they were 2 minutes long, and that was too long because people are driving, and they can only get like about 1 point. One joke at the beginning and 1 point in the middle that they can remember. I mean, and that is, and so that if they're inclined to share it, then that becomes part of their lives as well. This just bounced into my head. It's really not the best example, but I know one that we did that caused a lot of fear. It was kind of like if you use lavender scented bath products, boys can grow breasts. How inappropriate. But I remember that was really sticky, that, oh my God, and these mothers were using these herbal solutions and like tea tree oil and lavender, and it's kind of like, oh no, don't do that. But that is something that would stick in someone's mind, and they would certainly bring it up at dinner. And that would make a very pleasant dinner indeed, I'm sure. It's our job to heal. Bring people together. And enough to get them eager to hear another science talk. That comes out of the fireman's carry, is that when growing up, as I showed you with like my father and with his mathematics and eventually calculus, it's like sometimes kids get turned off early in school. I think K to 5 in science is kind of okay because it's hands-on and you're making those Mentos volcanoes and growing the bean plants in the little milk cartons. But around middle school, things start to go dark particularly. And so sometimes people are used to having science be something they don't understand, something that's not explained very well. So that if you can slow it down and make it like this exciting mystery or puzzle, that'll get them excited about science and all the things that it can do. So this is it's just before lunch. So I would usually play music, except we're not going to. So today, but maybe I'll hum it in the background. So I've been teaching, I've taught like over a couple hundred students here at UCI over the last 6 years. And one of my favorite assignments is the Ugly Slide Museum. One of my students is here. And that is where I ask students to bring in what I call the ugliest slides you've encountered in your academic experience. And over 90% of the time, they'll bring in slides of their very own professors or PIs. Again, what happens in Beckman stays in Beckman. But they bring in slides, and that's a little bit of going back to the culture of academia, where, once you have tenure, forget about it. You have your TA teach the class, you can have your TA make slides, you can do slides just from your own textbook, you can do anything. So this is just a bit of the cultural shift for you younger people, or the young at heart, of going to the next generation, where it is now, it's important to be able to communicate science better than it has before in the bad old days when my dad from Shanghai would fall asleep in his Caltech lectures. Okay, would you like to see some ugly slides? You want to see some really ugly slides? Okay, here we go. And usually I play the Godfather theme. Da, 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 da. And then they rate the ugly slides based on what I call the 5 Bs. Barf factor. That's when it just comes up and you go, that's so ugly. I don't think I'm going to be able to have lunch. Busyness, it's just really busy. Bad color, you're going to see that in a moment. Boring, just boring and you can't follow it. And then just bewilderment. Obviously, I smashed them into 5 Bs, but it's a little bit more memorable. Okay, cue the Godfather theme. Da, 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 da. The Rankine cycle, a very favorite one. This cycle has generated a lot of ugly slides. I think you see the first appearance of the royal blue and the cerise color combo. I don't know if it was early PowerPoint or something, but this upsetting combination of colors, you see a lot. Why do we see them? I don't know, but here's a guess for you. Ow! Oh, God. I mean, Jesus. Can you just what? Why? Why is that Comic Sans? What the hell is going on with these different fonts? So it was told to me that, it said that many scientists, more than average in the population, are colorblind. I leave you to discuss that at lunch as if it's true. So you see these like upsetting, like who would pick that? You're like, but if you're colorblind, it just all looks like brown, I guess, or something. Okay, so, ow. Okay, so this is, okay, obviously some problems occurred here, and you can't read these and it goes there, but again, this is ice shelf meltwater production. So this is important. This is climate change. These are the melting icebergs. So this is critical to get this story out. And a slide like this is not really going to be that helpful. Ow! Well, that's a lot more clear now, isn't it? Just the triangular format. It's right. Why did we ever think of that before? It's so some professor thought that this would make this simpler to follow. I like those colors a lot too. Okay. Ow. Let's do yoga to I don't know. Okay. Woo! Okay. Now this actually is from the internet. Like there's some professor making these, I hope not in this room, but people are downloading these for use, and it just looks like, Grand Theft Auto gone horribly wrong. And, but look in the upper left, isn't that exciting? Like what's going on there? Is it like, what? And then in moiety, it's just very nice. Okay, this is really a personal favorite. What going? But I love, don't learn any of this, illustration only. No need to learn the details in the handy shield format. Why? Why are we doing this? And the student who brought this in, I think this was the 5,000 slides this professor had, and I think it was his class, 5,000. And after a while, the students would just like the ice pack, they're not even trying to write them down anymore. But I think it was, although ironically, I think the student who brought this in said this was actually one of his best and favorite professors if you just ignored all the slides. So that's a good to know but it certainly is scary. And here finally is like my super favorite. Okay, so what's gonna happen is I'm gonna show it to you. And for the first 22.7 seconds, you won't know what's wrong. And then it will gradually dawn on you. Are you ready? Exactly. Relatively simple slide, an axis, a graph. What's this? What's that? It's the back of the student's head, because this slide is a classroom photo of someone else's slide. You see what's happening? So somebody sat here, like in the classroom, they took a photo of like one of my slides and then had it as their own slide. But you can see, but they have really credited the creator of the slide here in this handy black on gray format. Professor Ronald Rains, University of Wisconsin-Madison. So it's kind of like sometimes, yeah, some of these professors are so lazy, they're not even making their own slides, okay? So where does this leave us in conclusion? Okay. I'm saying that we laugh at some of this, but as I said, it's the next generation coming down, and this is changing day by day. They have magic screens. My 2 kids are now 17 and 19. One actually made it to college. I can't believe it. Hopefully the second one will too. But that even just a couple years ago, like middle school textbooks looked like this. They were $75, and this is what people were carrying around in their backpacks. And it's not really that appealing necessarily to every person. That just really makes it fly. Okay. Some of these textbooks, Campbell Biology, my younger child used, they're like 1,231 pages. So they're in these backpacks just being crushed by these books, which doesn't necessarily feel them, they're gonna dread having the homework, carrying that book around. In times when we have iPads and everything else, it's just really tough. And here's the infamous, sketch of the cell, which kind of like they see it about 8th grade, and it just looks like a stinky shoe with, worms coming out of it. And it's really hard. I've been through this a lot with my kids. This is just hard to understand. And it's just, and this is really our future. Our future is kids who are getting science given to them in this particular way. And then also there's often science textbooks, they combine a lot of reading and reading comprehension and safety and a bunch of things that they don't put in other books. And I think that it's really important for the next generation of young people to get excited about science, especially kind of, diverse populations of kids. There's just a lot of talent there. And I certainly know, like in my family with my dad from Shanghai, when the Nobel Prizes would come out, and we went to Caltech's Beckman's Auditorium every year for Alumni Day. When the Nobel Prizes came out, for him it was like the Academy Awards. It's like, who won? And he got it for his later, lesser work, not the earlier, better work in Stockholm in the 50s. And, so obviously my dad, Chinese, Shanghai, was just really a science fan, and that we were all going to do science no matter what. Or we were going to starve on the street. That's what he said for the three of us. And I can't say that I have proved him wrong as of yet. I like to say, I started in science, and then I went into the liberal arts, which to a Chinese dad is like pole dancing. We're so close to lunch. So close. Okay. And here's a big finish, pie in the sky. And that I think it kind of comes back to some of the themes that you've been hearing this morning. Although I have to say, I think the title, Wildflowers, Citrus, and Swimming Pools is fantastic. That's a fantastic title. So there's that. There's this important work that everyone is doing with the environment. There are issues of world frames and identities. And I think it really goes back to, I love what John said in that Yale study about curiosity. And this is interesting. Okay. And then we, can sometimes think in these times particularly of red versus blue. And I've, visited Texas and Illinois and various parts of the country where there's some more blue states and some more purple states and some more red. And we can think of it sometimes, it can feel like one is a blue state, or especially for California scientists, talking to a red stater, and that there's this kind of divide. And I think certainly with climate change, because Al Gore is really kind of personified the climate change discussion with an inconvenient truth, that seems like a Democrat thing. But I think that going on the idea of curiosity that John talked about, it's, but everybody loves fire trucks and 4th of July. I think about like the smallest towns in the small parts in those flyovers, the flyover states we Californians call it, that if you go to like a 4th of July fair, the fire trucks will be there. And that, Americans are really curious. They love how their smartphones work and kind of electric cars if it saves them gas money and going to the moon and traveling to Mars. It isn't really red versus blue. And I think of the idea of like a fire truck, that everybody loves fire trucks and firemen and firewomen because they are heroes. They do something that you see. And the way kids are clambering all over those fire trucks and looking at the hydraulics and the engine, and the ladders and how it all works, that really everybody can be excited about science and be curious if you tell the story in that humane way, using empathy and giving the why after the how. That's the end of my that seems the end of my PowerPoint. So thank you so much. Being a part of this day is fantastic, and you guys are doing great work and the work. You're the heroes, and tell your stories. Thank you.